All right, activity 3.3 is density. The density property states that between any two rational numbers, there is another rational number. Basically, there's an infinite amount of numbers on the number line, is what it's kind of saying. It can always be something smaller or always something in between. Now, the property is not true for natural numbers, whole numbers, or integers. So, for example, there is no integer between 25 and 26. There is no whole number or natural number between 12 and 13. And so we're just talking about rational numbers here. Okay. First, we have plot the given rational numbers, then plot and label a rational number between each pair of rational numbers. So we have 4 1/3 right here. And then we have 4 2/3 right here. An option for something that's between those two numbers could be something like 4.5. But you could have a whole bunch of different numbers, an infinite amount of numbers that are between those two numbers. And that's what the density property is stating. 5.5 and 5.6, something between 5.5 and 5.6 could be something like 5.55. Remember, 5.5 I could rewrite as 5.50. Or 5 6/10 I could rewrite as 5 60/100. 45 hundredths would be right here on the number line. And then 46 hundredths would be right here on the number line. Same thing, but now I can go to one further place. So I could put something like 0.455 between those two numbers. And again, I could add a 0 here. So it's 45 hundredths is the same as 450 thousandths. 46 hundredths is the same as 460 thousandths. I can add zeros to the end of a number until I'm blue in the face. And it still works with negative integers as well. I'm sorry, negative rational numbers, my mistake. Negative 45 hundredths, which would be right here. And negative 46 hundredths, which would be right there. Something that could be between both of those. And it doesn't have to be exactly in between. I was doing exactly in between, but I could have negative 452 thousandths, and that would be between those two numbers. All right. And I could have an infinite number of rational numbers that fit in between any two numbers. And that's what the density property is saying. Now, I've invited young Mrs. Lewandowski to join me because on this page, we have a situation where we're trying to do the same kind of thing, but we're kind of going back and forth here. So create a number line from 0 to 1. So I'm going to create a number line from 0 to 1 right there. Your goal is to plot and label a rational number closer to 1 than your partner. All right. Partner 1, Mrs. Lewandowski, would you like to give me a number, plot a rational number A between 0 and 1 that is close to 1? So give me an answer of A.
Okay, so I am going to give you 2/10.
2/10. Okay. That surprises me. All right. So I'm going to put A over here and I'm going to label it as 2/10. All right. I'm going to make this easier and I'm going to plot a rational number B, and my rational number is going to be 9/10. And so I'm going to make it so I have B right here, and then I'm going to make it so it's 9/10. Notice how I wrote it as a fraction for Mrs. Lewandowski, and then I wrote it as a decimal for myself because fractions and decimals are interchangeable. All right, it says now to repeat it 2 more times. So now you need to give me a number, Mrs. Lewandowski, that is closer to 1 than what I gave.
Oh, come on. That's why I started low. Okay, so I'm going to go for Okay, I'm gonna go for 99 hundredths.
All right. And so I'm going to put C on here, and then I'm going to put 99 hundredths as being closer. And then it says repeat 2 more times. So I was that 1 time, and then this is the next time. We'll go like that maybe. And then we'll continue. But let's see here. And I will make it so there is one here that's D, and then this point is 999 thousandths. And so that would then be closer. All right. So we'll do that for 1 and repeat 2 more times. That could be 1 time and we could go back and forth again. But let's just go and do the other examples because they're similar to this. All right. And so,
okay, so they could actually chat their friends and play this game with their friends.
This is a weird game to play with your friends, but yes, you could be like, all right, now get a number that's even closer to 1 because there's an infinite amount of numbers that are in between. There's an infinite number of rational numbers that are between any 2 numbers. I can keep getting smaller and smaller and smaller and smaller and smaller. All right. Number 3, create a number line from -1 to 0. So -1 would be over here, and 0 would be like over here. All right. You went first last time, so I'll go first this time. Thank you for doing this, by the way, Mrs. Lewandowski. I appreciate it.
Absolutely.
And so for this one right here, it says your goal is to plot and label a rational number closer to 0 than your partner. And remember, we're going from -1 to 0. And so I'm going to start with negative. So my point A is going to be negative 0.1, -1/10. All right.
Oh,
All right.
tricky.
So now you have to I have to think about this one because it's a negative number and a 0, and so it's a little bit different.
It is different. Okay, so now I want to get closer to 0, so it has to. All right, so now I want to I'm going to throw out the number.
Mm-hmm.
That means I have to have a 0 in the tens place to get closer to 0.
Yes.
So I'm going to say it's going to be a negative 0.01.
And this is just an approximation. Negative 0.01 or -100.
Can I say that in? Oh, you said it for me. I was going to say it mathematically. Sorry.
Yeah.
So that would be a negative 100th.
I try to go back and forth because I just want to make sure I'm able to properly say all of these as I get.
Agree.
Yeah. Then I need to get closer here, and mine is going to be right there, and it's going to be a C, and point C on here is going to be negative 0.002. And so it doesn't have to be the same number all the time, but this is -2 thousandths. And so that's closer to 0. And now you have to go again. You have to get it even closer to 0, but it's got to be between.
I could put like negative 0.0000000.
Let's do it.
52. And you're off the screen, I think.
That's about right. But now you got to say it. Let's see if we can. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths. Now you got to say it.
Okay. It's a negative 5,200 millionths.
That is nicely said. All right. And so you're welcome. And that's going back and forth for C. And now we have to go back and forth for this last one here. And so create a number line from -6. I'll put -6 over here. And then 2, -5. And so we're going to put -5 over here on the right. All right. Then we are trying to get a number closer to -5 than your partner. Do you want to go first or do you want me to go first?
Ooh, can I go first?
You may go first. Go ahead.
Okay. I'm going to start out with, let's see. Can I start out with, if I add a 0 onto 6, it'd be 6.0. I add a 0 onto 5, that's 5.0. So it would be 5.5 would be right smack dab in the middle. So it'd be closer to negative 5. So could I do a negative 5.1? No, I can't do that. Wait,
Yeah,
yes, I can.
Mm-hmm.
Yes, I can. Sorry. I was thinking 4 for a second. I'm good. Your hand was covering the 6.
It was my fault.
No, it's always your fault.
Okay. So you're saying you want to put on here as point A negative 5.1. Correct?
Yes, so yes, I do.
All right. Then I want to put as my point negative 5.0001. So I'm going to put negative 5 and 1 10,000. I think that should be like one of the things. You have to say the number for it to be able to go on there. You have to say it the right way for it to go on the number line.
Okay, did I say mine the right way?
I don't remember.
Okay, well, I'll say it again. Negative 5 and 1/10. Okay, so now I'm going to do, I'm just going to add a few more zeros in because I like adding zeros. So it's going to be a negative 5. I'm going to just add some zeros. So how many zeros do you have there?
3.
0, 0, 0, 0, 0.
Was that 5?
Sure, we'll go with 5. 4, 4.
4, 4. Okay. All right, now you got to be able to say the number.
Okay, hold on. Tenths, hundredths, thousandths, 10,000s, 100,000s. Where am I? Millionths and 10 millions? Did I do that right?
That is correct.
Okay, so it's negative 5 and 44 10 millionths.
Whew. All right, last one then. I can get it closer, so I'm going to put a little point in there. I was playing a game with the spinner for something I was doing, and I had to put the pen down in there, and it made a hole in the whole thing, and that's what's happening here. All right, point D, negative 5.12345. I'll just do that. Haha. All right. So that should be negative 5 and 33 10 millionths. Good?
I like it because 33 gets you closer to 0 than what 44 does. So I totally got that.
That gets me closer to right on the number line.
Yes.
All right. Then this whole idea here is the density property that I can put between any two rational numbers. I can put smaller and smaller and smaller. I can put numbers. There's room. There's an infinite amount of numbers that can go between any two rational numbers. I have some questions that we need to answer real quick, and then we're done. So there's 6 questions. We don't have to make it really long. Number 1, all whole numbers are rational numbers. Mrs. Lewandowski, what do you think?
I say that is true.
I also say it's true. What I like to do if I was a student is I would pause, I would try to answer it, then I would listen to Mr. Molnar or us in this case talking about this. Whole numbers, if I remember correctly, include 0, 1, 2, 3, 4, 5, and so on. And so then you do the 3 dots, the ellipsis, which means it goes on forever, infinity. Rational numbers is anything that I can make as a fraction that's a over b. And so I can make all of these as a fraction by putting it over 1. All right. Question number 2, true or false? All rational numbers are whole numbers. Mrs. Lewandowski?
Well, you just said that rational numbers is a over b. And let's see, whole numbers can be fractions, but not all fractions can be whole numbers. So I'm going to say false.
Oh, so like all squares are rectangles, but not all rectangles are squares kind of thing. So
Yeah.
there's rational numbers that would not be whole numbers. All whole numbers are rational numbers, but not all rational numbers are whole numbers.
Mm-hmm.
Whoa. All right. Um, okay. Next, 3. All rational numbers are integers.
I would have to say the same thing. That would be false.
I agree with you because it's kind of the same. This statement is the same as the one above. It starts with the rational numbers and then it goes to the other thing. And the one that we said was true started with the whole numbers and went to the rational numbers. And so now if I take a look at number 4. All integers are rational numbers. What do you say, Mrs. Lewandowski?
Oh, I would give that one a big fat true.
And remembering again that integers are basically all the negative numbers that are not all the negative numbers and positive numbers that are not fractional parts or like are not decimals. And so rational numbers, and these can all be written as a fraction of a over b by putting them over 1, so they are all rational numbers. That's hard to do. I keep on having to explain it, but then that makes it so it gets stuck in my head. All
Yep.
right, Mrs. Lewandowski, almost done. All whole numbers are integers.
Well, above you wrote whole numbers.
I did. I'm sliding it down. There's a lag.
Yeah, that's okay. However, oh no, I was just talking about the one right above it, number 4.
Here's all whole numbers.
Yep, those are all whole numbers. Yep.
Here's all integers.
Yep. But then
would all whole numbers be integers?
Right, and that would not be true, I think. All whole all whole numbers are integers, so that is true.
That is true. And then all integers are whole numbers.
No.
Yeah, that
because
is false.
Integers are negative numbers and whole numbers do not include that.
So the whole numbers are 0, 1, 2, 3, and then continues forever, but starts at 0. So all of those are some of the integers, but then the integers have the negative numbers as well. And since they do, then they would not, all of the negative numbers wouldn't be whole numbers. Whew. All right. So
Did it.
That's it. We're good.
Cool.
Thank you very much for going over that with me. I appreciate it. It was tough for me to figure out how to do that without talking to somebody else. So, ladies and gentlemen, that was activity 3.3 on the density property, which states that in between any two numbers, I can have an infinite number of rational numbers.